Hello students, welcome back. In today's class, I will be starting a new chapter, that is Upthrust in Fluids, Archimedes' Principle and Flotation. Till now I have finished almost maximum of the chapters. This is the 5th chapter. Okay. In this chapter we will be studying about upthrust, that is force in fluids. Fluid means liquid as well as gas. And the Archimedes' principle of how a body floats. The first topic which we are going to discuss today is buoyancy and upthrust. Okay, buoyancy and upthrust will be our first topic. Now, when a body is partially or wholly immersed in a liquid, an upward force acts on it. This upward force is known as upthrust or buoyant force. Now, if you can imagine, if you take a vessel full of water, a bucket full of water, if you try to put something like a small beaker or something over there, then what happens? The object will not sink as we put inside. It will float on top of the water. Now, the object will float. Even when we go for swimming and so on, our body floats in the water. Why don't we sink instead of float? That is the main question over here. That is because of the force which is applied by the water. And that force which is applied by the liquid, that is upward, is known as buoyant or upthrust. Upthrust is another name for force. Okay, so both this means force exerted by liquid, that is in upward direction. So if you put any object in the water, what happens? The liquid applies a force in an upward direction. So the property of a liquid to exert an upward force on a body, that property of a liquid to exert a force, that is upward force on a body, is known as buoyancy. Okay, this is the property of a body to exert or to apply some force on a body. Everywhere, I hope you have noticed that if you put any object in a water, if it is not heavy, if object is very light, then it floats. Okay, it depends upon the weight of the object also. That also we will study in detail. What happens if the weight increases or decreases? That depends upon the object and even on the liquid in which we are putting the object. So the property of the liquid to apply some force is known as buoyancy, and the force itself is known as upthrust. There is one example in your book, that is pushing an empty can into water. If you don't have an empty can, suppose an empty bottle. Empty bottle, if you close it tightly, airtight, and if you put in a bucket full of water, what happens? The can or that bottle will not sink, will not go inside the bucket, will float in the top of the liquid. So if you want to put it inside, what you have to do is you have to push that bottle. You have to push that bottle, you have to apply some extra force so that the bottle gets inside the bucket. Now as soon as you leave your hand, what happens? Again the bottle will come up to the surface. So you have to maintain a constant force. Okay, you have to maintain a constant force to let that object sit inside the bucket, or else if you leave, then what happens? The object will start floating over the surface. So if it is an empty can, airtight, then what happens? It will float, it will not sink inside. That is because the liquid is applying some force in an upward direction. Okay, the liquid is applying, water is applying some force, that is upthrust in an upward direction, which will not let the object sink. So for explanation of that, okay, in terms of force and gravity, we have to explain this. Okay, so explanation of that is when a can or a bottle is put in a tub of water, two forces act on it. So I have just drawn a diagram. This is a vessel full of water. So this is the surface of the water. This vessel is filled with water. Now if you put an object over here, what happens? This object, depending upon its weight, it will either sink or either float. Okay. Now there will be two forces applied to this object. Okay, this object will experience two different types of force. First one is because of the weight. This object has got some weight. Because of the weight, there will be a gravitational force. So because of the weight, it has some gravitational force. That is because of the weight. It will pull the object downward. That is the first one. Second one is, this liquid over here, this water over here, will exert a force in upward direction so that this object does not go inside. So there is a force applied by the liquid in an upward direction. Okay, that is the force applied by a liquid in the upward direction, which is known as buoyant force. It is denoted by FB. Okay, this B is for buoyant force. So there will be two different forces applied on this object. So now, if this two force is perfectly balanced, if downward force is equals to the upward force, okay, the gravitational force is equals to the upthrust or the buoyant force. If this is perfectly balanced, then what happens? This object will float. This object will float. It will float on top of the liquid. It will not go inside, but it will float exactly over there. So, if you want this object to sink, if you want this object to be there at the bottom of this water, what you have to do is you have to apply some force. You have to apply some force. But there is an interesting property of the liquid. Yeah, it's a very interesting property. That is, when you apply some extra force to push this object down, this liquid will increase the upthrust, or it will increase its force also. Okay, so if you put in extra force, this liquid will put more force to let this object not go inside. Okay, to let the object sit over there only. So there will be an extra force applied by the liquid. The force of the liquid will increase depending upon the level of the object. If object is on the top, force is less. If you keep on pushing this, then the force of the liquid, that is the buoyant force or the upthrust, will increase slowly. So it will reach its maximum value. Okay, this force of the liquid will reach its maximum value. But ultimately, what happens? This force or the force of the liquid will not be able to win. The maximum force of this upthrust is denoted by FB dash in your book. Okay, this is the maximum force of the liquid. As I have told you, when the liquid is on the top, the force is FB, that is the force applied by the liquid. As we keep on increasing the force outwards, like if you keep on pushing the object, then what happens? The force of this liquid will keep on increasing. So when we push this inward, the liquid will also increase its force. Do not let the object go down, but it has got this maximum value, that is FB dash. When it reaches its maximum potential, then what happens? This liquid will not be able to hold the force. It will not be able to hold the outward force. So what happens at that point? The object will sink. So when this FB, when this maximum force becomes less than the gravitational force, then what happens? The object will sink. Okay? The object will sink when FB is less than the gravitational force. Now when the gravitational force is more, when the downward force is more, okay, when the downward force is more, or the gravitational force, this is the condition where the gravitational force is more, when it is moving downward, then what happens? This is counterbalanced, that means the upthrust is counterbalanced by the gravitational force. Now suppose, if this upthrust is more, if this upthrust is huge compared to that of the gravitational force, suppose if you put an object in the water, then the weight of the object is very less, like an empty can. It has got few grams of weight. So if it is less, then what happens? The upthrust of the water will be there, that is FB, or the maximum upthrust, FB dash. So what it does is, it will not let the object sink, it will not let the object go down. So upthrust is more than that of the gravitation force. In this point also, the object will float. So these are the three conditions which you need to remember, at which point the object will float, at which point the object will sink. Now like liquid, okay, this is in terms of liquid. Like liquid, because liquid is made up of molecules, similarly we are talking about fluids. Fluid means liquid as well as gases. Like liquid, gases also have got the same property. So whenever there is a gas around, what happens? Our body is floating on that gas. Our body is floating. So the gas is also exerting, the air is also exerting the force or the upthrust or the buoyant force into every individual object which is there in and around, like in our body also. But because the weight of our body is huge compared in term to the force, we don't feel any force, we don't feel any upthrust. But the upthrust of the air is felt by very lighter objects like feather. Suppose there is a feather. If you drop a feather, it will slowly move down. It will take its time because the air molecules around is exerting an upthrust or an upward force on that feather. Like in the case of balloon. Now, inside a balloon, normal gas is not applied. We put hydrogen inside the balloon. Now, the density of hydrogen is less compared to the density of the air molecule. So, what happens when the density of the hydrogen is less? The balloon will float. The balloon will rise up because of the lesser density, the air molecule will push the balloon upward. That is why balloon rises up. And inside the balloon also there is hydrogen gas which is lighter in density compared to any other gas. So that is why some particles float in the air whereas some doesn't float. Whereas we don't feel any pressure or upthrust of the air, but lighter particles do feel the pressure and the upthrust of the air. So this is the basic idea of this chapter, that is upthrust in fluids. Okay, so I've just started with this small topic. In the next class, I will go in detail and the conditions and criteria of this upthrust. Okay, so before that, what you all do is just go through the chapter and try to understand it on your own. In the next class, I will explain you in detail about each and every term, what happens when density is increased, and there are many conditions and so on. So we will continue in the next class. This much for today. Thank you.